All right, so I'm going to go ahead and start. Thank you all for coming. Welcome to this workshop on how to secure your data computations efficiently. My name, Okay. My name is Mohamad El Hajj, and I'm here on behalf of Very Good Security, where I work as a security software engineer. This workshop today is going to start, I'm going to start with a small talk, and then I'm going to follow it with some demos, and then we're going to get into a hands-on coding workshop. So my talk today is structured into 4 sections. First, I'm going to give a brief overview of data security and its importance in data computations. Second, I'm going to define the attack surface exposed when computing on data. Then, I'm going to present the state-of-the-art solutions currently available for secure data computations. And finally, I'm going to introduce a new tool we're developing here at VGS called Starlarky, which enables us and you to compute on data securely and efficiently. So let's talk about data security and why it's important. Data is an asset. It's a commodity, it's fuel for the economy, and it's of high value. But data, I think there's like a signal issue. But data is also a liability. Breaches, hacks, and leaks lead to identity theft, loss of customer trust, reputation damage, financial loss, and possibly even complete loss of a business. So with data comes great responsibility. And so it's critical to understand how to secure your data computations and why. Data, okay, I'm gonna not use that. So data lives in 3 states on our systems. At rest, when it's being idly stored on disk, in a database, or on the cloud. In transit, when it's being transferred from one point to the other over the network via HTTP, SFTP, or email. And in use, when it's being transformed and computed on inside our applications. But for the sake of this talk, let's assume we know how to secure data at rest and data in transit via encryption, proper authentication, SSL, and what have you. And let's focus on data in use, because data in use is the state of data where computations happen. It's an important and arguably one of the most vulnerable states of data. Why, you may ask? Well, while data in use is when data is consumed for value extraction, it's also when data is decrypted and exposed in plain text. It's when data is transformed by potentially untrusted code, whether that be a developer we trust who's prone to human error, or untrusted third-party code. And it's when data is exposed on a shared system, where potentially untrusted code may be running in parallel on the same host. But even with these risks, we still need to extract value on data via computation. And so the question I want to answer today is, how can we compute on data securely using untrusted code? Let's start by defining the attack surface. What can the adversary do? The adversary can write code to transform data and execute it on company infrastructure, the code that is. This exposes a wide attack surface to the adversary, from code vulnerabilities such as buffer overflows and in-system calls, to arming the adversary with system access, such as the file system, the network stack, system clock and timers and logs, to possibly even hardware side channels, such as Spectre and Meltdown. And finally, it gives the adversary control over CPU and memory resource usage, giving them the ability to possibly DDoS the underlying hardware. So as you can see, this is quite the attack surface we need to secure against when doing data computations. And before I go into what we're doing here at VGS to secure these data computations, let me present to you the state-of-the-art solutions for confidential computing and what they have to offer. How do these solutions go about answering this question? How can we compute on data securely using untrusted code? Well, for most of them, it really boils down to isolation. Executing untrusted code in isolation under a zero trust model. And isolation comes at different granularities with varying security guarantees. At language runtime, such as Denoland and Chrome V8, at the process or OS level, using sandboxing, such as Google gvisor, and process isolation techniques, such as CNAMEs and AppArmor. At the hypervisor level, using VMs and micro VMs, such as AWS Firecracker and Hyper-V. And finally, at the hardware level, using enclaves, such as Intel SGX and Nitro enclaves. And isolation at different granularities is achieved via different methods. At the language runtime, it's achieved by limiting or disallowing access via whitelisting to host IPs, host names, and directories in the file system, and reducing time of precision. At the process or OS level, isolation is achieved via OS virtualization and process separation, sometimes even complete re-implementation of system calls. You can really think of these as hardened Docker containers. At the hypervisor level, it's achieved via complete OS and hardware simulation and strong virtual separation between the host and the VM. Really here, the VM tries to rely as little as possible on the host it's running on. And finally, at the hardware level, it's achieved via physical separation on chip. For example, partitioning the memory unit per enclave. And with isolation comes trade-off. The more isolation we have, the more security guarantees we get, but at the cost of performance and usability. You can imagine that you can imagine that deploying a hypervisor, like a VM or an enclave, gives us more security than that of a language runtime, but the time it takes to learn how to and actually deploy them is much larger, and it's at the cost of performance. And if we look a little deeper, while the ultimate goal for these solutions is to enable secure compute, it's also to enable the use of general purpose languages. But when it comes to data computations, that's really like bringing a bazooka to a gunfight. Why? Do we really need to use languages that were created to build complex systems and complex applications for just data computations? And just like with a bazooka in a gunfight, while it's unnecessary, if it backfires, it can be catastrophic. If we look at common data transformations, so these are like the common ways we compute on data in our applications, you'll notice that we really don't need, it's not necessary to use general purpose languages to achieve this. We don't necessarily need network access, or we don't need access to the file system or logs or timers, right? And rather what we're really doing by enabling general purpose languages is enabling developers to write unsafe code and enabling attackers to compromise our systems. And so now the question really becomes, well, how can we compute on data securely without using these expensive isolation techniques? And this is where Starlarky comes in. Starlarky is a programming language we're developing here at VGS for secure data computations. Starlarky achieves isolation at language granularity. So Starlarky is a programming language that is secure by design, and it's based on Google's Starlark programming language. What are the core components of Starlarky? First and foremost, security. And in the next slide, I'll talk more about how Starlarky achieves security. Second, usability. So Starlarky is not a general purpose language, and it's not intended to be used like one. It's not intended to be used to build systems or route network traffic. Rather, it's intended to be embedded into your application as a data transformer. And following that, we get performance. Because Starlarky runs inside your application, it runs in process. You don't need to deploy a separate stack, make any network calls, and it doesn't require any expensive virtualization that consumes a lot of resources. Finally, familiarity. Our goal with Starlarky is to have developers to start using it easily and quickly by reducing the learning curve. And this is why Starlarky is a Python-like syntax, given that Python is a familiar language to most developers today. These 4 components sit at the heart of Starlarky. What about security? How is Starlarky secure by design? Well, Starlarky is a hermetically sealed language. What does that mean? It means no access to the file system, the network stack, timer, system calls, system clock, or logs. It's also deterministic. So it limits resource usage by bounding object sizes and forcing loop bounds to be deterministic, which means no infinite loops, no loops based on conditionals that that are like input dependent. Shared objects in Starlarky are immutable, which provides for secure thread-safe execution. And finally, Starlarky has bounds checking, just like Python, which mitigates most buffer overflow-like attacks. What about trade-offs? What are we trying to, if you look back at the trade-offs, what are we trying to achieve with Starlarky? We're trying to maintain performance and usability as much as possible, but minimize the security trade-off. But as we know in life, there's no free lunch. And so we're gaining security by sacrificing functionality. And here, this is by design, because what we're trying to do is we're trying to strip away the features in general purpose languages that are not needed in data computations and that might be deemed unsafe. Well, now you might be wondering, well, what about complex use cases where general purpose languages are necessary? Machine learning algorithms or running data scans, such as antivirus scans, et cetera. Well, I tell you here, in these scenarios, we need to compromise and use these complex isolation techniques. But these are not the common data transformations that we use on a daily basis. Now, let me get into a small demo and show you how to embed Starlarky into your applications, and I guess how easy it is. So can you guys see this? Should I? Interesting. OK. I'm going to give 2 examples. Right now, we can embed it into Java, and we can embed it into Python as a data transformer. So here, I'm using Java, and I use Maven as my dependency handler. And really, all you need to do is, so we use GitHub packages as an artifact deployment. And so here, all you need to do is you need to configure the GitHub package repository for Starlarky and just inject this Lorc API that we call it. Maybe it's good to give you kind of an overview of Starlarky first, the repository. You guys can check this out during the demo as well. Really, so Starlarky is based on Google's Starlark language. And this is where this lives, in the Starlarky repository. And then we have Larky. It's all the additional features we introduce over Starlark to enable all the data computations that we need and to build them securely. Lorc API is just a wrapper around Larky just to make it easy to use. So it's just basically like a Larky runtime engine. And then Starlarky is what we use for Python. So let's go back and look at this in action. So here, this is the Lorc API. What the Lorc API gives me is this, where is it? This engine, right? And with this engine, what I can do is I can just execute script, and I give it my script, and then I'll discuss these in a bit. Let me show you how a script looks like in Larky. As I said, it's a Python-like syntax. So, oh, okay. It's lagging. All right, so as you can see, instead of import, we just do load, and then everything else pretty much looks exactly like Python. But as you're familiar with Python, usually you get input either from the command line or you're reading something from a file. Here, because it's embedded into your application as a data transformer, the way we inject inputs and extract outputs from Starlarky is via global bindings inside your engine, which means that here you can see I have script input defined and script output defined, but script output is not consumed anywhere, and script input is not defined anywhere. And this is what I do inside my Java application. So if we go back to here, I'm getting my code source and my input file from somewhere, and then I extract them as strings. And then I use something called a script context, which inside it has bindings. And these are the bindings that are the global variables inside your application. So you can see here, if I go up to the definition of this input binding key, it's the script input that we saw was being consumed inside the application. And I can set it inside the bindings and then put this context as the engine context. And when I execute the script down here, using the engine on this input context, oh, well, this is actually redundant. I don't need to do that. It basically injects this script input, and then I pass this output binding, which extracts the script output that you saw here, and I have it defined up here. So as you can see, it's really simple. You just build your input, and then execute your script, extract your output, and that's it. So I'm going to start by showing you this regex example. Really, this regex example, regex, let me show you the input first. The input is just some text with credit card information, when it expires. And then I just run a regex to extract any 16-digit number and anything with like this date format. And then I execute these two functions on the script input, and I set the script output to be a formatted string with the output of these regex statements. Let's see, I commented some code on the fly, but this should work. Let's let it run and build, and there you go. So all it did is, here, I'll show you, this function, it just gets the file names that you see over here, puts it in a pair, and then we just read we extract the script and the input. We put the input in the binding, and then we set the script and the binding, the context in the engine, and then it executes. This is pretty much the idea. Let's look at some more interesting examples. At VGS, we have this Vault API where you can redact and reveal your sensitive data. And so this basically gives customers the ability to maybe do some pre-processing before they redact and post-processing after they reveal, et cetera. And then here you can see that it's as simple as loading the Vault module and doing secret.redact. get token, and then return token into script output. And if I run that, I'll show you the input. So the input is just the same credit card number. Tokenization. And then what here I'm expecting is I'm giving it the credit card as an input, and I'm expecting a token as an output. And I hope this is not too small. You guys can see how this is like a randomly generated token. At VGS, we also have different formats. You guys can check our docs for that. Let's get into maybe some security features. Here, I talked a bit about loops, no infinite loops. So the way in Python where you can introduce infinite loops or condition loops is using a while statement. And actually, the while is not a part of the syntax, a part of the Starlarky language. So if I even try to execute, let's see, loop fail. If I try to even execute the script with while in it, it's gonna throw an output. It's gonna throw an error telling me that while is not defined. While is not supported. Use for instead. Hope you guys can see that. And if we look at a passing example for, you can see that I define here a list, and I give the list into the for loop, and this is the only way you can actually execute a for loop in Starlarky, by giving it an iterator. And this iterator, you can't modify it inside the loop. So you can't like keep on expanding it and turn it into an infinite loop. And then I'll just show you, like, if I just run that example out of the box, it's gonna pass, right? It just gets me the sum of the elements in this list. But if I try to do something like, oh, Siri wants to talk. If I try to do something like mylist.append 6, and I go and try to run this again, you'd expect that it shouldn't let you. And then here, you can see it tells me list value is temporary immutable. So the iterator for the loop is immutable. You can't modify it inside the loop. All right, same thing with recursion. This is a Fibonacci recursion example. You know, recursion is a type of loop, and we know anyone who's dealt with recursion's a nightmare. Let's see what it gives us. Called recursively. You can't do that. Okay, finally, since we talked about that Starlarky is a Python-like syntax, this follows that for us who are familiar with Python, can we write code in Python and automatically transform it into a Starlarky code? And the answer here is yes. We have this tool called Py2Star. And all you have to do is clone it, set it up, run the setup.install, and then Lorc Api. And let me show you this really quickly. I have them right here. So I clone it. I go into indexing. Py2Star. Python, I'm going to create a virtual environment. And then a virtual environment, if you guys are familiar, if not familiar with it, it just lets me install like my own packages inside this virtual environment, and this way I don't have to pull you all the libraries I have running on my system. And then I run Python install. It's really quick. Let's wait for that to run. And I'll show you the example meanwhile. So this is the Python example. It uses JSON to, so we extract the input from from the command line. Obviously, this is Python, so we can do that. This script input gets handled by this function that just loads the JSON input, extracts the card number, redacts it, and then puts the card number back into the input JSON and dumps it out. And you can imagine, like, if you're doing a HTTP request that's JSON-based, this is kind of exactly what you do to redact your card number. And obviously, after we convert this from Python to Larky, we need to sanitize it just to, for it to match with the engine interface. Okay, so as we can see here, everything's been downloaded. So now I go into another PyTest, like internally where like PyTeststar actually lives. And then, well, before I show you the Larkification, what I'm doing here is I'm executing the script using Python. This doesn't want me to zoom anymore. Hope you can see it. But what I did here is I executed this Python script that lives here on a JSON input and just showed you how my function, if we go back to this function, the redact returns token. And that's exactly the output I got here. So now if I Larkify, I'm gonna go back to my README, what this does is I run this Py script and then I give it Larkify, and I just give it the same Python script. And I output it into what we call a .star file, which is for Starlarky. Here, I'm just doing some directory traverse. I'm just traversing some directories just so it shows up back here again. And then so after Larkify happens, I should expect a new .star file to show up. And as you can see, it's kind of just one-to-one mapping. Instead of import, we load, and then everything else more or less stays the same. But if I run this now, as you can expect, let's go back to this. sys.argv should not actually work. We shouldn't actually be able to get anything from the command line. And let's see, this is JSON. What's the error that I get? Sys value has no field argv. Let me sanitize this a little. Remove the print. I'll just do handle script input. This will be injected into my application. Let me do something a bit. Let's use the VGS vault instead of this simple redact function. And then I'll do vault.redact. Very simple, right? And this is like what we'd actually do. Oh, there you go. Hope you guys can see that. Pretty much the same output. And I didn't show you the input, but it's just a JSON with the card number. So I hope this was helpful as far as Java is concerned. Python, I'm not going to dwell too much on it. I'll most probably make this public after this workshop, but really all it does is you just pip install Pylarky, and then you have this evaluator, which is very close to the Java interface. You just give it the script, you give it the input, gives you the output, and you're done. All right. Yeah, so that was Starlarky examples. And before we get into the workshop, if you guys have any questions, I'll be happy to answer them. This is the QR code for the Starlarky repository, so feel free to check it out. And yeah.
For the for loop example you gave, I'm guessing a generator would not work, right? As an iterator. You need to have a defined list, right?
Well, you can use range. For example, you don't have to have a defined list, but it has to be deterministic at runtime. So if Yeah, you can't have infinite. Yeah, like it's gonna take the iterator object and it's gonna make it immutable. So a generator would, if you had a generator in there and it would like generate a new list at runtime, that would try to like modify the immutable object that is the iterator, and then it would just fail. It would go like you can't modify an immutable object. Yeah.
So if the Starlarky code is running inside your application, I'm assuming it has to like decrypt maybe like let's say you're taking in a card number or something. How does that play with like PCI compliance code? Like then do I have is my application in PCI compliance code?
Yeah, very good question. So this application, like the way we use this at VGS is we use it inside our own applications, which are already in a PCI environment. So the customer that's going to use this code, or the developers that are going to use this code, they're going to be able to compute on the raw data, but they're not going to be able to have access to it. Like they can't leak it into the logs, they can't print it out, they can't see it in any way. And it's like the whole cluster is set up in a way where it's PCI compliant, you know, with like password protection and all of that.
Oh, so the code is actually run on your infrastructure.
Right.
That's how I would. Okay.
So if you were to use Starlarky on your own system, what Starlarky would give you is it would reduce the attack surface of anybody who's writing code to compute on the data. But obviously, where the application lives, it has to live in an environment that is PCI compliant. Right? But if you're like PCI compliant by default, Starlarky won't enable features that will break your PCI compliance. Yeah.
So is the main use case for Starlarky for semi-trusted third-party
Yeah, exactly. So we provide like secure features that you can use as a developer, and then like third parties can come and they can write their own code with Starlarky, and inherently that code would be secure. And then so like if we want to run the code on our infrastructure, we don't have to like worry about are they like doing anything like directory traversing, trying to find executables to do some privilege escalation, stuff like that. Yeah.
Do you have any plans to target additional languages outside of Python and Java?
So not right now, because mostly like most of our work is like with Java and Python. But I feel like as the community grows and as like people start contributing more and like bringing in their own use cases, we hope that like one day we can integrate with more languages. We do have like a workaround around that where you can deploy like a function as a service using Starlarky, and kind of that's what we're going to be building today in the workshop, where you can, like you can deploy your own Lambda function service and just query it with your Starlarky stuff. Yeah. We are like at VGS, we have this deployed in production, and we have a lot of customers that are using it, and they love it because like data analytics and data computations, when you don't actually have access to your data, is such a pain point. And it's a pain point for like both companies, right? Like our customer like wants to compute on their data, but they can't, and then they have to ask us to like write custom operations for them, and then like we have to go develop it, maintain it, et cetera. Great question. Any other questions? Cool. So yeah, workshop. So like I said, what we're going to do today in the workshop, we're going to kind of try and get to 3 things. How much time do we have? Okay, we're running good on time. So the first thing we're going to do is we're going to build kind of an on-demand function as a service server, which lets you query the server with a Starlarky script and input, and then it would just like execute on demand. You don't have to containerize your function. You don't have to like build a VM around it, like an AWS Lambda, stuff like that. Second, we're gonna create a custom module And here the use case is, sometimes you have like a backend service or maybe some endpoint you want to use, like third-party endpoint for like KYC or what have you, and like you want to enable access to it inside Starlarky, but you don't want to enable the unsafe features that are needed to create such a module. And so there's flexibility to actually do this in Java. So do the implementation in Java, make sure that's secure, and then just expose an API into Starlarky using this module. And third, contributing to Starlarky. So we're just gonna be quick. Like how can the community write their own modules and contribute to Starlarky? So that's the QR code for there's a repository for this workshop session, and it has most of the agenda, like detailed instructions on how to do that. So if you guys can just grab that. And the QR code is also on the next slides. So if you don't get it just now. All right, so building a Starlarky function as a service. So QR code for the project skeleton, that's the link if you prefer. And I have it opened right here. I can walk through the agenda right here. So the first thing we want to do is just set up the environment. We are using Java here, and the project skeleton is using Maven. So that's really all you need. Just get, like SDK man is like, it's like an all-in-one kind of, so you can like install Maven and Java, and then just set your Java home to the SDK man's current Java installment, and you're done. Optionally, there's an option where you can even Dockerize your deployment, and this way, you can test it through Docker, you can deploy it in your Kubernetes cluster, whatever. But this is optional. The infrastructure is there, but you don't have to have Docker if you're not going to use it. There is a simple client. This is a gRPC service. So I'm using gRPC curl and YQ just for like wrapping. Like I just created a wrapper which really simplifies your experience of like writing the script and querying the server. So I have the code right here. Let's go to the main point. So what you want to do is you want to go navigate into your Java source, and you just want to complete this template over here. As you can see, this was actually, like the code is exactly the same as what I demoed. And then you just have to, build it yourself, create the input bindings, and then just invoke the engine using its API, which is like easy to find. You just go into Larky runtime, and then you have the engine right here. So you have the interface. And then you extract the output, and then the output gets built into these gRPC messages, so you don't have to worry about that, and it sends it back to you. So all the networking stuff is taken care of. All you have to do is inject the input and invoke the engine after the setup. So I'll be around. You don't have to use an IDE if you don't want to. You can use any IDE you want. You can use Vim. The README has instructions on how to like run and execute, especially using Maven. Here you can run it. You can run it with Java. You can build it and run it with Docker if you have Docker installed. And then this simple client, I can walk you through it really quickly. This is once you deploy the application on your machine, this is pretty much where it runs. It just listens on port 6565. And then you just send it your script and your input. And you guys can like play around with this as well. This is kind of the same tokenization script that we saw before. And you can just check out the Starlarky repository for different modules. Yeah, so I'll be around. I'll give you guys like, say 10 minutes to just figure out how to like build the server, deploy it, run some queries against it, and if you have any questions, I'll be happy to help. So does anybody need help? Or everything? All good? Okay, so I do have like a out-of-the-box solution ready for whoever like didn't have time to finish it or just wants to check it out, maybe having some trouble, see like what it was done differently. It's in the README right now. It's under solutions. It's under like solution right here, and I'll just show you the code and kind of demo run it. So I have it cloned here. Let's see. Wow, I can barely read this. So this is the server, and I'm just gonna do maybe clean. Okay, just so all the red stuff goes away. I promise it's not a bug. So like I showed you, really the solution is you get this gRPC request in that has a script and an input, and here I can show you the proto file. It's right under proto. So there's a request with a script and an input, and then a reply with just the output. And then your gRPC service is just compute, give me a request, and I'll give you the reply. And then under the hood, just extract the script, extract the input. Where is it? Yeah. So set the bindings. So input to this script input binding, and then you extract the output, which is the script output. The thing I do differently here is the script that is sent. Let me show you what kind of script is sent in the simple client. It's like a Lambda function, right? So you don't actually invoke the function. It's just like a predefined function called handler. You put all your code inside this handle function, and the engine, like the server, just invokes it for you. And that's kind of the idea of kind of how function as a service servers are implemented. And then so here I just do it really simply. I have this invoker, and what it does is it takes the script, and then it takes this invoker line, which is output binding equals handle function, consuming the input binding. And then so that becomes your full script with the input in the script context, and you just pass it to the engine. And then the output, you build it into the gRPC message, and then you send it on its way. So let's see that in action. Let me see what happened here. Okay. I guess maybe it wants me to just build it from here. So like you can see, the compilation is just super fast. And why doesn't this red stuff want to go? Try and run this. Sorry, I promise it worked when I tried this earlier, but we call this the demo effect. See, See, it's right here. Interesting. Okay. My IntelliJ wants me to fail, and I will not let it. So I will just run it from the command line. Aha! So server started, you can see it's listening on port 6565. And if you look at the client, if you look back at this client, what it does is it gets the proto, it queries the gRPC service running on port 6565, and it sends it the script and the input. And so let's do that. Let's just call the simple client. Boom, output. Our card number got redacted. And I can really like do kind of, I don't know, whatever I want here. I can return potato, and then I'd have to rerun the server. Did I spell potato wrong? Oh, I have to run it. And then simple client. Now it's potato. So yeah, you guys can just like take this home as a toy example and build on it if you want to use it. And now what we can do is implement over. There's a custom module. If you go under modules, there's this custom module, and this is pretty much how we create modules inside Java for Starlarky. So all you have to do is you need to implement this Starlark value. You can think of this like this is like the object class in Java. So it's the source of all objects. So you just implement the Starlark value, and then you define methods. So here, this method is do something with its parameters, and this is just for docs. Actually, no. Depending on what you're doing, this can be important. Like if you want to give it a default value, and then this should work out of the box, but it doesn't do anything. It just like returns your first and second parameters. So you guys can like play around with this, do whatever feature you want. And the way, since we're not baking it into the Starlarky repository just yet, the way you inject this into your application is also through bindings. And the example's in the README, but same idea. You just put the object, the Starlarky, like the module object, into a binding, and then you can call it by just doing the name you defined here, custom dot, whatever method name in your module, and then give it the arguments. Sorry? Okay. Mm-hmm. Yes, exactly. It's implemented in Java as well as a Starlarky module, but that lives in the Starlarky repository, and that's why you can load it. In the next section, I'll show you how you can actually take your custom module and then put it in the Starlarky repository, so you do load. But for now, because it's not in Starlarky, you can't load your custom module, and then you can just invoke it as an object. And you can consult the README for this as well in the workshop repo. Yeah, so what I did here is I didn't change anything to this custom module. I kept it the way it is. But in the service itself, I filled in the code and I added this binding, which has this new custom module. And then what I did is I modified the client script to invoke custom do something, and then just give it like a first parameter and second parameter. And then once I invoked it down here, kind of the output was exactly what I returned, the output of this do something function, which just returns a concatenation of the two strings. Cool. Okay, so how can you contribute to Stardarky? Well, just first thing is to clone the Starlarky repository, and then I can do this live. Clone the Larky repository and go to, there's two ways to contribute. You can write a Starlarky module, so like just purely Starlarky code, which lives, as we said, Larky is the, like where all your features and modules will live. And then all the Starlarky code lives in resources. And here you can see like when we were importing things, we had like stdlib, JSON. So you can come down here and you can, JSON is a Java module. regex. So like if I do load regex, this is basically the file that gets loaded as a module. So all you have to do is you write your own star file. You come and you put it in here. You commit, push, and there you go. You just build a new Starlarky jar file, and that's it. If you want to contribute, let's do this, and then I'll show the Java contribution. So I'm going to go ahead and actually do all the steps. Let's do it right here. Actually, I can open the terminal. Well, let's do it down here. I'm just going to clone. Just opening the project I just cloned. This is fresh repository. I'm just going to wait for my IntelliJ to load the Maven module. Boom, there we have it. And then, like I said, so Larky, source, main, resources. Let's put something under here. Let's do this. New file, custom.star. And then, so I'm not gonna really do anything fancy, but I'm just gonna, you can like look at other examples, how they do it, but I can define custom right here, and then pass it a function, right? So I can define my do something function here that takes param1, and then param2, and then what it does is it does return str param1 plus str. It just makes them into strings, in case it's not strings, and then it returns them. And then it's really just like a one-to-one mapping. Sometimes you can have like internal functions that you want to not expose or expose. So just do something equals do something. And let's see. Now if I'm going to build this jar file. So this jar file is going to be built locally. Let me just do like a fresh example. Show you it's not pre-built or anything. So I'm just going to change the version to 1.0 fintech. And then right here, Larky. Let's do from the root. Clean, install, skip tests. And we'll just let it build. What this will do is it will create the jar file for me and then just put it in my local stash. And then I can just grab it in my other application. And now, like, I'm building a module, so it's no longer injected via the binding, so I'm gonna actually have to load that module. Success. Does anything ever work from the beginning? Well, we can't know yet because we haven't tested it. So 1.0 fintech, right? That's what we called it. Yep. Let's see if it finds it. And then Where'd this 5 come from? Oh no. Let me see. Oh, I know what happened. I changed it naively. Okay. Let's do this. I should have done Maven set version. So only Starlarky took the different version. Everything else stayed a snapshot, but that's okay. It serves the same purpose. So we go back, we come into this POM file, we do snapshot instead of fintech. And sync. So now what I do is I'm gonna go to my module, to my engine here, and I'm gonna remove this custom module that I built. And then in my script, what I can do now is I can load this custom module, right? Well, okay, I don't need vault, so I'm just gonna replace it. Then do custom, and then custom. And then, yeah, we had 2 parameters, everything should be the same. So let's run this. Let's turn off this old server that was consuming resources. And run it again. Actually, I can just run it from here, right? It's running. Moment of truth. Okay. What happened? Oh, I know what happened. See, that happens when you copy paste without preparing. So to use the Larky struct, I actually have to import the Larky module inside my module. And that's when I can create the struct. So let's do this again. Now everything's set up, so I just have to rebuild the Lorc API. Let's wait for this to build, turn off our server. It's building lots of stuff. There we go. And then now I just rerun this. It's running. Boom. There you go. Thank you. And then just to verify that it is using the custom module that we just created, we'll just rerun the server. Oh, I didn't have to rerun the server. Oh, we'll just try another script with removing the import. Tells me error, custom is not defined. So this is how you contribute just using a Stargarchy module. And this is pretty much like customers can, I mean, they can't specifically like write modules for themselves, but they can write the like all the module functions in their own script and like create their own private modules that they just deploy and run in VGS. And then so to contribute a Java module, what you would do is you would go into the Java part, so not resources, you go into the Java implementation, and then there's modules right here. And then you can see here, I can show you like where the Vault implementation is. This is the Vault module. So it implements, Vault module is a bit special. It implements an interface just for Vault, which implements Starlarky value. Oh, sorry, this is a bit messy. Which implements Starlarky value, and these are like the redact and reveal functions that we were seeing. So you would just copy paste your custom module here, and I mean, we can do that. You just copy paste this custom module right here. And we should be A-okay as long as we don't have conflicting modules. So let's go and remove this guy. And then now what should happen is I should be able to import this, and I'm gonna rebuild just while I talk. I should also be able to import this custom module the same way, but now its implementation is in Java. So here you can do like more complex examples, like access a backend service, for example, that you have. Yeah. Just wait for this to build again. And as you can see, like it's really trivial how easy it is to actually contribute to this programming language. Mm-hmm.
Limitations or suggested boundaries on commit or on pull requests?
Yeah. So limitations. I mean, limitations would be the backend service that you're accessing needs to be secure, right? It needs to, like, if it's something that you're going to contribute into Starlarky using Java and it accesses some backend service, then it also needs to be something that is like widely used and available. So, for example, if there's like a common KYC interface, then that would be something great to implement into Stardarky, right? We included a like PII analysis interface, and then like at the back end, you can use like Amazon's PII or Microsoft's PII engines, which you can deploy.
Is there like a requirement that that can be like open source, or is it?
No. So with Starlarky, like you deploy it on your infrastructure, and the way we integrate things like that use backend services is through what's called Java SPI. It's a service provider interface, and what you can do is you can override that at runtime. And I can show you here how, like, I am actually doing it right now, but I didn't include it into my demo. So here, the Lorc Vault, you can see up here, it's super small. I can't zoom that in, but like the Lorc Vault, this is the Lorc Vault SPI. And so I defined in this example to use just the default vault. So this is like the built-in into Starlarky. But what I can do is I can implement something that I can like implement a new vault, my own like custom vault module that overrides the redact and the reveal functions. And then I just change it here, I do like custom vault, and that implementation can access your backend service. And so this SPI interface lets you like have a common interface, but you can access your own implementation. And this way you can go from using Amazon's PII analyzer to Microsoft PII analyzer like super easily. Yeah, so we built this custom module into the Starlarky, and we generated the jar. Let's turn off the service and run it again just so it picks up the new jar file. And let's go back and import this custom module. And let's run it. Is it going to work? I might be missing something with. with the built-in stuff. Oh yeah, no. These custom modules are a bit, there's just one more step that I forgot. And so modules that are in Java are not picked up automatically, and they actually have to be injected into this immutable map. So right now, like all the modules are baked into the language. We do have we're working on changing this and having it like you can load your own modules at runtime, and this way you can also reduce the surface for your engine. And so I'm just gonna have to rebuild this. I really hope this is helpful. We're really looking forward to having the community contribute to this language, since it is open source, and we do hope that the community can also adopt this language for their secure compute, anything secure compute they do. So I'm going to rerun this. Fingers crossed, guys. All right, and then it's running. There we go. Super easy. All right, so this, let me see, I think this concludes contributed to Starlarky. Oh, yeah, there's one more thing. So you can download the PyTostar, and instead of actually having to build your own module in Starlarky, you can do it in Python and port it to Starlarky. Or you can find an existing Python library, and then you can easily port it to Starlarky and kind of, clean it up, remove anything you deem unsafe or you don't want as a feature. And you just copy paste that file into the directory and you're done. So yeah, thank you for coming. This was super fun. I hope this was helpful. I hope to see you guys, contributing to this project. And if you have any questions, you want to connect, please, reach out to me on LinkedIn, and thanks.